Okay, so this is going to be a review of the last two topic quizzes you took. We took one on solutions and we took one on redox. So I'm going to go through all the questions on the quiz so that you can understand what you did wrong. All right, the first question says, a solution consists of 0.5 moles of CaCl2 dissolved in 100 grams of water at 25 degrees. Compare the boiling point and freezing point of 100 grams of water at standard pressure to the solution. So they give you all this information, and honestly, really the only thing that you need to look at is CaCl2 and water. That is it. Everything else is irrelevant. I told you that covalent compounds are only considered one piece. They don't separate when they dissolve, but ionic compounds or compounds with polyatomic ions separate into their respective ions. So you've got one Ca and you've got two Cls. So that's a total of 3 pieces. So the more pieces that you have, the higher the boiling point will be and the lower the freezing point. So the solution has a higher boiling point and a lower freezing point. Number 2, what is the molarity of 1.5 liters of aqueous solution that contains 52 grams of lithium fluoride? And they gave you the GFM of lithium fluoride. Well, molarity is moles over liters. And you're asked to find molarity, so that's your X. And you have liters, 1.5, but you don't have moles, so you can't solve this problem yet. So you need to do a mole calculation, which is moles equals given mass over GFM first. Your given mass is 52 and your GFM is 26. So 52 divided by 26 is 2 moles. So now I've got 2 moles divided by 1.5, which is going to give me 1.3 molar. What is the mass of ammonium chloride that must dissolve in 200 grams of water at 50 degrees? This is a Table G question. Now, notice that Table G is for 100 grams of water. So you either have to be intuitive about this and see that they're asking for 200 grams of water and double your answer, or you can set up a proportion. So at 50 degrees, if I go to Table G and I follow it up to where it intersects ammonium chloride, I'll see that that is about 52 grams. So I have 52 grams in 100 grams of water. So how much will I have when I have 200 grams of water? So you can see that this is going to be double. That's going to be about 104. Which compound is least soluble in water at 60 degrees? This is also a Table G question. You're going to look at 60 degrees and see which line you get to first. And the first line that you get to is the KClO3 line. Base your answer to this question on the information below. An unsaturated solution is made by completely dissolving 20 grams of NaNO3 in 100 grams of water at 20 degrees. What is the correct numerical setup for calculating the number of moles that was used to make this unsaturated solution? So, moles equals given mass over GFM. And they tell you that you have 20 grams and the GFM is 85. So which one of these shows 20 divided by 85? Well, that's going to be this one, because it's number 2 is 20 times 1 divided by 85. And not only that, if you did this dimensional analysis wise, how I showed you at the beginning of the year, you'd have 20 grams, and you know that 1 mole equals the gram formula mass. So there's your setup right there. grams cancel, and that's what that is. 6. Under which conditions of temperature and pressure is a gas most soluble in water? Well, gases don't like to go into solution. So if you're going to get a gas into a solution, you need to force it in, like CO2 in soda. So CO2 is forced into soda under high pressure, and it's got to be low temperature because we want the molecules close together. If we have high temperature, the molecules are going to be spreading apart, and that's going to make it even more difficult to put the gas into a liquid. Copper can be used for water pipes and homes. When the pipes corrode, copper atoms oxidize to form Cu2+ ions in water. So we're going from Cu solid to Cu2+, just so we know what's going on. A homeowner has a water quality report prepared for a sample of water taken from the pipes in the home. According to the report, a 550 gram sample contains 6.75 times 10 to the negative 4 grams of dissolved copper 2+ ions. Okay, so far we don't need that. Using the diagram below, draw 2 water molecules in the box. Well, I've told you 100 times that water is polar. And I've also told you that the element with the higher electronegativity gets the negative charge. So the oxygen side is slightly negative, the hydrogen side is slightly positive. And we know opposites attract. So if this is my water molecule, I'll draw it a little bigger. Here's my H2O, then this side is negative and this side is positive, which means that when you drew your molecule, and everybody did it wrong, well, not everybody, 90%, the negative side had to be facing the positive Cu2+, because like charges repel, opposites attract. Okay, explain in terms of molecular polarity why the solubility of methanol in water is greater than the solubility of methane in water. We know this. If something dissolves in water, it's because they have similar polarity. So methanol is more polar, is more polar than methane. And not only that, you can see from looking at the diagram right here that methane is non-polar. It is non-polar. Methanol is definitely polar because the north and south cancel out, but the east and west don't. There is pull here. There is going to be pull in this direction. Okay, let's see what we got going on here. Show a correct numerical setup for calculating the mass of carbon dioxide in a 100-gram sample of air taken in 1980. Well, in 1980, we know that the parts per million are 338.7. So this is a parts per million problem, which equals grams of solute over grams of solution times a million. So our parts per million is 338.7 equals, they want us to calculate the mass of carbon dioxide. So we don't know what that is, but what is our, we have a 100-gram sample of air times 10 to the 6th. If you did this right here, just like that, I gave you credit. I did. I would have really have preferred you to take and divide out the 10 to the 6th on both sides, leaving that. But if you did the first thing, that's fine, but you had to at least have had that. 10. Explain using information from reference table F why the symbol AQ is used to describe the product ZnCl2. A lot of you did not use table F. You need to follow directions. If you look in table F, Cl, which are chlorides, okay, are soluble. And Zn is not an exception. There are 3 exceptions listed for chlorides, and it's silver, lead, and mercury. So therefore, since Zn is not an exception, then it would be soluble. So that's what I needed you to write there. All right, let's go to the redox quiz. Which process occurs in an operating voltaic cell? Remember, voltaic is this type of cell right here. It is a spontaneous reaction that produces energy. It is chemical to electrical. You have to memorize it. It was part of the Venn diagram. What is the oxidation number of manganese? Remember that all compounds are neutral. Oxygen is -2. That gives me a net -8. This whole thing, when we're done, has to be equal to 0. K can only be +1. Therefore, you do the math here. Mn has to be +7. This is what I'm looking for. The numbers up top, not the numbers at the bottom. That just helps you do the math. What occurs at one of the electrodes in both an electrolytic cell and a voltaic cell? Well, the same thing happens. Leo says Gur. Loss of electrons is oxidation, gain of electrons is reduction. And the same thing happens as far as red cat anox. Reduction is at the cathode, anode is the oxidation. And in both of them, electrons always flow from anode to cathode. So let's see what's going on. Oxidation occurs as electrons are gained. No, electrons are lost. Oxidation occurs as electrons are lost at the anode. Leo, loss of electrons is oxidation, and red cat, anox. Anox, the anode is oxidation. There's our answer. Reduction occurs as electrons are gained. That's true, but not at the anode. It's red cat, reduction at the cathode. So that's not true. Reduction occurs as electrons are lost. Nope, Gur. Gain of electrons is reduction. Total number of electrons gained must equal total number of electrons lost. This is the law of conservation of charge. And we had that on a vocab quiz for those that did that. Equal to the total number of electrons gained. There we go. All right, I got a voltaic cell here. How do I know? I see a salt bridge. Salt bridge is flow of ions. Ions in this bad boy. Okay. Identify the anode. So we know anox, right? Red cat, anox. Reduction at the cathode. Anode is oxidation. So which one's being oxidized? I can do this 2 ways. I can look at the equation, Ni0 going to Ni plus 2. When I lose electrons, I become more positive, so this is oxidation. Or I can just not mess around with the equation, go straight to table J, and nickel is above silver on table J. So this is my anode, and this is my cathode. So nickel. The anode is and the cathode is always going to be an electrode. It's always going to be the solid metal. Given the balanced ionic equation, which half fraction represents the reduction occurring? So Al is by itself, it's 0. That's got a charge. This has got a charge. Cu is by itself, it's 0. So I got Al going to from 0 to Al plus 3. So this is going to be oxidation, because when I lose, I become more positive. And I got Cu2 plus going to Cu0. This is gain of electrons, because when I gain, I become more negative. So this is reduction. So I know I need the Cu1. So now I got to balance. So if this is +2 and this is 0, I got to add 2 electrons to the left, because a +2 and a -2 is 0, which matches what's on the right. In reduction, you're always adding electrons to the left. In oxidation, you're always adding them to the right. Which energy conversion occurs during the operation of an electrolytic cell? Electrolytic cell, this is the one that requires a battery. So this is non-spontaneous. So here you've got electrical energy going to chemical energy. So we need a battery source to drive the reaction. Write a balanced half reaction for the oxidation that occurs. So Mg is by itself, H2 is by itself, Cl is -1, so H is +1, Cl is -1, but there's 2 of them, so -1 times 2 is -2, and Mg is +2, and we know that because this 2 right here, when we cross and drop, we can go up and over, came from that. So we need oxidation. Leo, loss of electrons is oxidation, and when I lose, I become more positive. So that's going to be my Mg going to Mg +2. That's my oxidation. So Mg going to Mg +2, and I need the electrons on the right because a +2 and a -2 balances the 0. All right. Which statement identifies the part of the cell that conducts electrons and describes the direction of the electron flow? Electrons always flow through the wire, and they flow from what's been oxidized to what's been reduced. In this case, Zn is above nickel in table J, plus I can look here, 0 to +2. That right there is oxidation. Ni to 2 to 0, this is going to be reduction. So they flow not through the salt bridge, through the wire from Ni to Zn. Nope, we said Zn was oxidized, so from Zn to Ni. So this is oxidized, this is reduced. Flows from what's oxidized to what's reduced, or from anode to cathode. Last problem. Right away, I see that this is an electrolytic cell, and the object to be electroplated is at the cathode. This is the cathode. And I also told you in an electrolytic cell, electrolytic ends in C for cathode, and it starts with electro, and that's like electron, so cathode is negative. So if I trace back my cathode, oops, there it is, attached to the negative electrode. So the reduction occurs at, so red cat anox, reduction is at the cathode. That's going to be A, which is the cathode. All right, that is it. I will do the other ones, try to get another one done tomorrow night. Looking to do sig fig review tomorrow night, then naming, then bonding, then nuclear.